Welcome to Bar Island. Bar Island is one of the several islands in Frenchman Bay. The island attracts attention because of the sandbar that connects to the shore of Bar Harbor. Locals and visitors can walk to the island on this sandbar during the low tide. They enjoy it as part of the Acadia National Park trails and the views from the top of the hill.
There are two types of bedrocks on this island. As you can see in the picture, the southern part of the island is the Bar Harbor Formation. On the northern side, we can find gabbro-diorite, which is the majority of the island. Bar Harbor Formation formed 465 million years ago. These rocks have been tilted because of tectonic activity. Magma from a supervolcano that existed 420 million years ago intruded the Bar Harbor Formation. This magma cooled down and formed gabbro-diorite.
Bar Harbor Formation is sedimentary rock formed by deposition of marine sediments. Gabbro-diorite is an igneous rock that is mafic and intrusive. As it is intrusive, it cooled down slowly, so it is coarse-grained. Also, there are felsic granite dikes around the gabbro-diorite. This was most likely formed by melting of crust, as it is felsic and rich in quartz and feldspar.
Sedimentary rocks tend to fold or tilt because of tectonic activities. Bar Harbor's tilted formation is a type of fold that is on the island as part of anticline fold. When the fold dips towards the opposite sides of the hinge, it is called anticline, as in the figures 1 and 2. The hinge of this fold is present in the shore path of Bar Harbor. The fold is dipping to the northwest on the island in a 201-degree angle, and the strike is in northeast to southwest direction. Based on this, Bar Island should be somewhere in the fold, as it is marked in figure 1.
When the continental glaciers flowed over the island from 30,000 to 16,000 years ago, they shaped the island into Roche Montagnaise landform. When the glacier advances, it puts pressure on the upstream side of the mountain, creating a gentle slope. This causes abrasion on the other side, turning it into a steep slope. The occurrence of Roche Montagnaise landform from north to south shaped the Bar Island. Also, the glaciers and other forces of nature carried granite boulder on the northern part of the island. Such boulders are called erratic boulders, and there are many on Mount Desert Island.
Tide plays a big role on this island. When the tide is low, a naturally occurred sandbar appears. On the east side of the sandbar, there are many boulders, big stones. On the other side, it is only full of sand. As a guess, we think this difference happened because of the wave current. We made a small picture to explain this more clearly. When we were at the sandbar, the wind was blowing from the northwest and the waves from that side were powerful. But on the east side, the current was low as the wind blew away from the sandbar, and also the strongness of the wind was decreasing as it was blocked by the island. So as the currents tend to be more powerful in the west side, more erosion happens. This results in the formation of more sand than stones. But on the other side, erosion is very low as the current is also slow. Therefore, there are more big stones than sand in this area. What if the wind pattern changes and blows from a different direction? It is still the same. If the wind blows from the northeast direction, it gets disrupted by the island. If the wind blows anywhere from the southern direction, the wind is already weak as it met with many obstacles before it reaches the shore.
Mount Desert Island is a paradise for geologists all over the world because of the amazing landscapes that the Mother Nature has gifted.
So, before we put the full stop, we strongly suggest you to come and enjoy the nature and the wonder of rocks.